Hello everyone, welcome back to STEM for Others. Today we're going to be talking about unsupervised learning. So, if you've been following along with the machine learning videos, you know what unsupervised learning is, and we've also talked about this before, and we've also had a whole video on supervised learning. So, you should know the clear distinction between the two. So, take a minute before watching the rest of the video and just try to make a list in your head of what you can separate between unsupervised and supervised learning. Pause the video, think about it, and then once you're ready, we're going to go through the definition. Okay, hopefully you're ready by now. So, unsupervised learning is a type of machine learning where algorithms learn from unlabeled data. So, this is the key point, it's unlabeled. You're not telling the machine what it's seeing. So, seeking to discover patterns and structures within the data without explicit instruction or guidance. So, we have an example here. Imagine you gave a robot a smoothie with 10 fruits inside, but you didn't tell the machine which fruits they were. So, could the machine figure out what fruits were inside? So, that's what we're going to figure out today. So, how do machines actually figure out patterns? It's not just like out of thin air. There's actually some pretty important steps to it, and this is what we call feature engineering. So in machine learning, we usually give a computer a data set. Sometimes we also give it labels, like this is a dog, this is a cat, if you're looking at two pictures, and that is supervised learning. So it's where you're telling the machine what these things are that you're feeding it. And then for unsupervised learning, we just hand it a pile of data and say, you have to figure this out. We don't give it labels, we don't tell it what it is. So when the computer doesn't have any, or when the machine doesn't have any labels, it has to figure it out through patterns, and it has to look closer into the data, and it focuses on things called features. And these are things like color, shape, height, or speed. And to find patterns, they use feature engineering, which you create these features and the computer looks into them. So they look into, say you have an image, it will look into pixels and it will convert it into a numerical value that the computer can actually read to then classify these certain images. Okay, so what exactly is feature engineering? So feature extraction is how a machine learning model takes raw data like pictures, sound, numbers, anything you give it to the computer, and then it pulls out the most important parts. Those are the important features. So it's turning messy, complex information into a clean list of useful clues. So why does this matter? So raw data is too complex for a model to use directly. It has to kind of translate it into something that the computer can read and analyze so then it can give you an actual prediction. So feature extraction picks out the most useful traits, color, shape, speed, anything that relates to the type of data that you're giving it, so the model can find patterns. And this is kind of like giving a robot a smoothie and asking it which fruits are inside. It can't see the fruits, but it extracts features. So you give it, like, they have the sweetness, the color, the texture, and those are the certain things that it uses to figure out what's in it. So it's like giving you basically like context clues or clues to kind of figure something out. That is what is going on with feature engineering and feature extraction. Okay, so now we're going to get into what is clustering. We already talked earlier about some classification algorithms, and clustering is just like, it's not a specific algorithm, it's not a specific algorithm, but it's a type of classification. So clustering is like sorting, but the computer decides how to group things. It finds things that are similar and puts them in the same group. Example, like sorting socks by color, size, or pattern without being told how. So here we have an input of some baseballs, basketballs, and soccer balls, and in the model you can see all these numerical values because it's taking each of these images. I guess these are images because that's what they are on the screen, but it's converting these pixels into a numerical value where they are picking out maybe the color of it, something about it that if you see black, in this shape or whatever in this pixel. It's converting that into a number. So, and then that's how the computer is actually looking at this. They're looking at the numbers and they're aligning it with the images, and that is how the computer is actually going to group the baseballs from the soccer balls from the basketballs. So it's not like the computer is actually looking at all these different types of balls like we are, like humans are. It's all translated into something numerical so that the computer can actually really understand what's going on and see this numerical pattern. Okay, so that is all for today. Next time we're going to be talking about reinforcement learning, but thank you so much for watching.